Hey everyone, and welcome. Today we're diving into the new frontiers of AI research. And let me tell you, we're going way beyond simple calculations. We're not just looking at what AI can do today, but at the massive challenges researchers are tackling to make it truly reliable, sustainable, and smart enough for the real world.
So, here's what we've got on deck. We'll kick things off by defining AI's next big frontier. Then we'll break down the 5 core research challenges. From there, we'll see how it all comes together in a real-world example, touch on the tech that makes it all possible, and then wrap up with the key takeaways and a final question to chew on. All right, let's jump right in. The entire field of AI research is, well, it's shifting. The old goal was pretty straightforward. Just get the right answer. But the new frontier, it's way more ambitious. It's all about building AI that we can actually count on in really complex, unpredictable situations. This quote really hits the nail on the head. For AI to be a real game changer for organizations like the armed forces, it's got to do more than just crunch numbers. It needs to be able to handle real-world problems, run efficiently, and actually reason about things over time. And what this all boils down to is that we're redefining success. See, it's no longer good enough for an AI to be technically correct. The new gold standard includes things like fairness in its decision-making, being transparent about how it works, and, maybe most importantly, earning the trust of the people using it.
Okay, so let's break down exactly what researchers are zeroing in on. We're about to walk through the 5 core challenges that are really defining the future of AI.
Okay, first up, let's tackle challenge number 1, robustness and generalization. And this one is absolutely fundamental. I mean, this is what separates an AI that's a genuinely useful tool from one that could be a real liability. It's one thing for an AI to work flawlessly in a lab, but it's a whole different ballgame to make it perform reliably out in the messy, unpredictable real world. A huge piece of this puzzle is defending against what are called adversarial attacks. Now, what are those? They're basically clever, deliberate attempts by an opponent to fool or manipulate the AI's logic. So a truly robust system has to be smart enough to spot and push back against these kinds of tricks.
All right, on to our second challenge, efficacy and sustainability. And this one is huge because look, the most brilliant AI in the world is totally useless if it costs a fortune to run or if it practically needs its own power plant. The reality is, training these massive models takes an incredible amount of energy, and that's just, well, it's not sustainable. So the goal here is pretty simple to say, but incredibly hard to do. Make AI more efficient. Researchers are working on new ways to get the job done with fewer resources, which lowers both the environmental and the financial costs, all without taking a hit on performance.
Now, this next one is where things get really fascinating because it gets to the heart of what true intelligence is. We're talking about moving AI from just spotting patterns to actually understanding cause and effect. You see, most of today's AI is amazing at finding correlations in data, but it doesn't really get why those things are connected. This challenge is all about teaching AI to understand the why.
And what that means in practice is we need an AI that can handle complex timelines. It needs to understand not just that event B happened after event A, but how A might have caused B, and what all the ripple effects of that relationship are over time.
Challenge number 4 is all about multimodality. Just think about how we humans experience the world, right? We see, we hear, we read, we feel. We take all these different sensory inputs and blend them together to get a really rich picture of what's going on. The goal here is to give AI that exact same ability. And this is what paves the way for something called embodied intelligence. When an AI can process multiple senses at once, you can put it inside a physical body, like a robot, and it can start to interact with the world and learn from its surroundings in a much more natural, intuitive way. And that brings us to our final challenge, lifelong and few-shot learning. As it stands now, if you want to teach an AI something new, you usually need a mountain of data and you have to retrain the whole thing from scratch. This research wants to make AI learning a lot more like human learning, efficient and nonstop. So this idea really has 2 parts. First is few-shot learning, which means the model can pick up a new skill from just a few examples. The second part is lifelong learning, which means it can add this new skill to its toolkit without completely forgetting everything it already knows. It just keeps getting better and better. Okay, so we've just gone through 5 pretty high-level challenges. Let's bring this all down to earth with a practical example that ties everything together, a conceptual reconnaissance robot. This example just perfectly shows how it all works together. A robust robot won't get fooled by camouflage or weird shadows. A sustainable one can run for days on a small battery because its AI is super efficient.
And a multimodal one can combine what it hears, like a drone, with what it sees, like movement, and what it senses, like a heat signature, to build a full picture of a threat.
Now, none of this advanced research just happens on its own. It all relies on some incredibly powerful, specialized hardware, plus a really clear framework to guide how everything gets developed. So let's take a quick look at what's under the hood. On the hardware front, two of the big players are something called ASICs and TPUs. Think of ASICs as custom-built chips that are hyper-efficient at doing one specific thing really, really well. TPUs, on the other hand, are specialists for all the heavy lifting of machine learning, making that large-scale training way more efficient. You really need both to push the envelope.
And here's a fantastic way to visualize the whole framework we've been talking about. Imagine that main goal, the AI research targets, right in the middle, held up by these 5 essential pillars: robustness, sustainability, causal reasoning, multimodality, and lifelong learning. This is a perfect way to lock in those core concepts.
All right, let's wrap this all up. We'll quickly recap the most important points, and then I'll leave you with one last thing to think about.
So when you boil it all down, the future of AI isn't just about getting smarter. It's about becoming more dependable and more efficient. It has to be robust, it has to be sustainable, and it needs to actually understand cause and effect. It will bring together different senses through multimodality and learn on the fly with few-shot learning, all of it powered by specialized hardware.
And that leads us to our final question for you to reflect on. When you think about field operations, where power and resources are always scarce, why is that second pillar we talked about, efficacy and sustainability, so absolutely mission critical for the armed forces when they deploy AI? Something to think about. Thanks so much for watching.